It wasn't just a bomb. It wasn't just an aircraft. During the final months of World War II, Japan created a weapon so extreme that it blurred the line between machine and human sacrifice. A rocket-powered aircraft guided by a pilot who knew there would be no return. This was the Yokosuka MXY-7 Ohka, a manned missile designed for a single devastating purpose. By 1944, Japan's situation in the Pacific had become desperate. Allied naval forces were pushing closer to the Japanese mainland, and conventional tactics were no longer enough to stop them. Aircraft losses were mounting, fuel was scarce, and experienced pilots were becoming increasingly rare. In response, Japanese military planners turned toward extreme solutions. The idea was simple but terrifying. If accuracy was the problem, remove the guidance systems and replace them with a human pilot. This concept led to the creation of the Ohka, a weapon intended to strike Allied warships with unmatched precision. The name Ohka translates to cherry blossom, a symbol of beauty and sacrifice in Japanese culture. Allied forces, however, gave it a far less poetic nickname, the Baka bomb. Airframe and structure. The Ohka Model 11 was built with simplicity and speed in mind. Its fuselage was a narrow cylindrical tube measuring just under 20 feet in length, with a diameter of less than 2 feet. At its core was a lightweight aluminum airframe reinforced by longerons and internal formers. Thin aluminum sheets were riveted over the frame to create the outer skin. This kept the structure extremely light, allowing most of the aircraft's weight to be dedicated to its warhead. The nose section was covered by a single-piece cowling designed to house the massive explosive charge. The wings were relatively short, spanning just over 16 feet. They were built from aluminum spars and ribs but skinned with balsa wood to reduce weight. Simple ailerons provided roll control, while the aircraft's tail used a twin horizontal stabilizer design. This configuration helped balance the heavy nose and provided stability during high-speed dives. Warhead and destruction power. The most striking feature of the Ohka was its warhead. The long nose section was almost entirely filled with an armor-piercing explosive encased in hardened steel. The total warhead weight exceeded 2,600 pounds, with over 1,100 pounds of that being explosive material. The weapon used a complex fuse system. A contact fuse in the nose ensured detonation upon impact, while additional fuses at the base acted as backups. Some of these fuses were armed by the pilot shortly before release, reinforcing the weapon's one-way nature. Once detonated, the Ohka was designed to penetrate the hull of an Allied ship before exploding internally, maximizing damage far beyond that of conventional aerial bombs. Rocket engine and propulsion. Mounted at the rear of the aircraft were 3 solid-fuel rocket engines. These engines provided immense thrust for a very short period of time. Solid rocket motors work by igniting a pre-mixed propellant that burns rapidly, producing high-pressure gases expelled through a nozzle. Each engine contained multiple cylindrical propellant sticks arranged to burn evenly from the inside outward. Once ignited, these rockets could not be shut down. The pilot had full control over when to activate each engine, but once lit, the burn would continue until exhaustion. Combined, the engines could propel the Ohka to speeds of up to 400 miles per hour in level flight and over 580 miles per hour during a dive, faster than most Allied aircraft could intercept at close range. Cockpit and instrumentation. Inside the cockpit, space was extremely limited. The pilot sat surrounded by basic flight instruments, including a compass, altimeter, airspeed indicator, and turn and slip gauge. These instruments were essential during the unpowered glide phase before rocket ignition. A rocket selector dial allowed the pilot to choose which engine would fire next. This staggered firing sequence helped extend the weapon's limited range. Electrical switches controlled fuse arming, engine ignition, and onboard systems. Communication with the carrying bomber was achieved through Morse code, using a simple signal system. Once released, however, the pilot was completely on his own. Flight controls. Control systems were intentionally simple. A basic joystick controlled pitch and roll, while yaw was managed through a rudimentary footbar connected to the rudders. These controls were sufficient for the Ohka's single task, guiding the aircraft directly into its target. Because the rocket engines could not be shut off, every decision had to be precise. A mistake in timing or alignment could result in missing the target entirely. Launch procedure. The Ohka had no independent takeoff capability. Instead, it was carried beneath a Mitsubishi G4M Betty bomber. The bomber transported the weapon toward the target area at high altitude, conserving the Ohka's limited range. Approximately 50 miles from the target, the pilot crawled through the bomber's bomb bay and entered the Ohka's cockpit. Once inside, he removed safety restraints that prevented accidental control movement during transport. Moments before release, the canopy was sealed, the engines were set to standby, and the warhead was armed. A final Morse code message confirmed readiness. When the bomber released its payload, the Ohka drifted away, marking the point of no return. Flight and attack phase. After release, the Ohka began an unpowered glide, accelerating to speeds between 230 and 280 miles per hour. During this phase, the warhead fuses became fully armed. As the target came into view, the pilot ignited the first rocket engine. Acceleration was immediate and violent.
The Ohka would
Once the first
impact
engine
above
burned
the
out,
waterline.
the pilot selected the next,
Instantly,
conserving the
the
final
wooden
rocket for the
and
last
steel
moments of
structure would
attack.
disintegrate.
With 2 engines expended, the aircraft became lighter and faster. The final rocket pushed the Ohka to maximum speed during its terminal dive, giving enemy ships little time to react. Impact and effect. The Ohka struck just above the waterline, where ship armor was weakest. Upon impact, the aircraft's wooden and aluminum structure disintegrated instantly. The steel-encased warhead continued forward, piercing the hull before detonating inside the ship. The resulting explosion caused catastrophic internal damage, often leading to fires, flooding, and severe structural failure. Despite its terrifying design, the Ohka had limited strategic success. Many carrying bombers were shot down before reaching release range, and the weapon's short operational window restricted its effectiveness. However, the Ohka remains one of the most extreme examples of human-guided weaponry ever deployed, a symbol of desperation, innovation, and the tragic cost of war. The Ohka was not just a machine, it was a message, a final attempt to turn sacrifice into strategy. And while it failed to change the course of the war, it left behind a chilling legacy that still forces us to ask how far nations will go when defeat seems inevitable.